Hello everyone, welcome back. In this presentation, let's focus on the relational algebra natural join operation. We have been addressing the relational algebra additional operations and we are now in the natural join operation. Before stepping into what is natural join, let's understand the basics of join. What is basically a join operation? A join operation is the combination of two operations. One is the Cartesian product, another one is the selection process. So what we are going to do is that when we have two or more tables or relations, we are going to perform the Cartesian product among all the tables. Let's take two tables as an example. Just perform the Cartesian product of both the tables. After the Cartesian product, we will be having a lot of tuples, right? Let's say relation 1 has 4 tuples and relation 2 has 5 tuples. The Cartesian product output will give 4 times 5. It means 20 tuples. 20 rows will be there in the output. And this is not just Cartesian product, right? The join operation is not merely a Cartesian product. After performing the Cartesian product, we're gonna apply the selection process by giving some condition. And that's what join operation is all about. It means literally we are going to join two tables or two relations based on some join condition. And this join condition is actually specified in the selection process. I know things will be a bit unclear at this stage. No worries at all. Once you complete this lecture, you will be gaining better insights about the join operation, and particularly we will be understanding inner join operations elaborately. So what does it mean? This join operation pairs two tuples from different relations. Let's take two tuples, one tuple in one relation, another tuple in another relation. We are going to join these two tuples from different relations. And can we just like that join? We are going to join two tuples from different relations if and only if the join condition is satisfied. Actually, the Cartesian product gives the combination of all joins among two tables, and then we are going to apply the selection process which takes some condition, and this condition is the join condition. So basically, the join operation is combining two tables by giving some condition, and this condition is called as the join condition. Now when we talk about the join condition or join operation, how they are done? They are done in multiple ways. However, in this presentation, we gotta focus on inner join. Let's focus on inner join now. What is inner join? Actually, inner join also is going to join two tuples from different relations. And after performing the inner join, the output relation will have only those tuples that satisfy the matching criteria. To say, only those tuples that satisfy the matching criteria are included in the output table. So when we join two tables, the join output will contain only the matching criteria. No worries, when we see an example, you will understand what it is. Let's say when we have tuple 1 from one table and tuple 2 from another table, and if the join condition is matched, obviously these two tuples will be matched in the output table because the join condition is matched. If the join condition is not matched, what happens? It's just discarded. So this inner join discards row or rows of either table that do not match any row of the other table. It means if the join condition is not matched, that will not be there in the output table. So in simple terms, if join condition is matched, they are included in the output table. The rest are excluded in the output. If you still need clarity, we are going to see some examples in the coming slides. Then it will be definitely easy for you to understand. Now let's see the types of inner join. Basically, inner join is represented in the following three ways. Number 1, the theta joint. Actually, this is the join symbol. It means two triangles are joined together. This symbol is a generic symbol. However, it depends. There are some conventions which uses different symbols for representing join operation. I am giving the generic notation. So the first inner join is the theta joint. With this join symbol, I am representing theta. Coming to the second type of inner join, which is the Equ joint. And here also I am going to represent with the theta symbol. I know you will be confused. If we represent this, that is the join symbol with theta, does that mean theta joint or Equi joint? Actually, both are one and the same with some differences in the predicates or in the conditions. Don't worry, just hold on for a few more minutes. Anyway, this will be addressed shortly. And coming to the third one is the natural join, which is the topic of this day, the natural join operation. This natural join is also inner join only. We are done with the basics of inner join. Let's first start with theta join. Talking about the theta join, it is represented with the join condition theta. What does it mean? This theta join is basically a general case of the join operation. So as I told you, this is the general notation. However, if you want to be very specific, then it will be an Equ joint or it can be an inner joint. For now, we will understand it is a general case of join operation where this is also known as a conditional join. Remember, this join operation cannot be performed without some conditions. And basically, when conditions are involved, then it is also known as a conditional join. So, theta join is also known as a conditional join because it also uses join conditions in order to combine or join two or more relations. And we know it is represented or denoted by theta symbol, which is this join operation. This is theta symbol. So, this is theta join. And why do we want this theta join? It's obvious. This is used to join two or more relations on some conditions. So if the condition is satisfied, two or more relations can be joined together. I mean, tuple 1 from one relation is going to be joined with tuple 1 of the other relation if some conditions are satisfied. So to make this process simpler, just perform the Cartesian product where we will get the output which contains the tuples from both the relations are joined together. Then we will apply the join condition. So let's see the syntax now. Suppose P and Q are two relations, and if we want to apply the theta join, it is P theta join Q. What does it mean? The relation P is going to be joined with relation Q with the help of theta join, where this theta will be having some conditions or predicates. So theta is referred as the condition or the predicate. This predicate means it's basically the condition. Now, when it is a condition, obviously, it will have some operators, right? To be precise, it will have some conditional operators. What are the conditional operators this theta will take? The conditional operators theta takes are equal to, not equal to, lesser than or equal to, greater than, and greater than or equal to. If these operators are used as the conditional operator in the theta, then it is basically a theta join. In case we use equal to only in the theta, then it is actually the second type of join we are going to address, which is the Equ joint. However, as I told you, this theta join is a general case of the join operation where we can use all these operators. If we use equal to, then it can be specifically referred as Equ joint. We are going to see that elaborately in the coming slides. So in general, a theta join is performed like this. We know P theta join Q, it means it is the Cartesian product. After the Cartesian product is done, just perform the selection with some condition or the predicate. And this predicate will definitely use any of these operators. Let's see an example now. This is an example for theta join. Let's take two relations. I'm going to perform the theta join. Can you see this is the join condition? S1, relation 1's SID attribute should be greater than R1 relation's SID. You see, if two relations have common attribute SID, it means the student ID. In that case, we can go for this theta join. Remember, this is the join condition. If we are going to perform a theta join, the condition here is S1's SID should be greater than R1's SID, where S1 and R1 are two relations. Let's take some input table. Here is S1, which contains four attributes: student ID, student name, rating, and age. And it has some values. I mean, it has some rows or tuples. Then let's take the other relation, which is R1. This contains student ID, branch ID, and date. This also contains some values. Now, if you observe, this theta join or inner join is possible only if there is a common attribute. Can you see here? this student ID is available here, and this is also available in R1. So this student ID is the attribute or the common attribute that is available in both R1 relation as well as S1 relation. Now we can perform obviously theta joint. To save some space, I am not going to just perform the Cartesian product. However, if the Cartesian product is performed between S1 and R1, the output is going to be 6 rows, right? So this row is actually going to be combined with all these 2 rows. Then this row will be combined with these 2 rows, and this row will be combined with these 2 rows. So we will be getting the output table as 6 tuples. And after that, we are going to apply the join condition, which is this, where SID of this S1 relation, which is this, should be greater than the SID of this R1 relation, this. So obviously, this is the join condition. Let's take this row as an example in S1 relation. So S1's SID 22. Let's first match this one with the first row. So the SID of S1 relation, is it greater than SID of R1? No, they are equal. So 22 is not greater than 22. 22 is greater than or equal to 22 is fine. But here the join condition is simply greater than. Obviously, SID of S1 is not greater than SID of R1. So this will not be there in the output. And coming to this row, let's join with this row. This SID is definitely not greater than this SID because 22 is not greater than 58. So this row will not be joined with this row as well as this row. Now let's take this row and we will combine this with this row as well as this row. This row can be combined with this row. The reason is this is greater than this. Obviously, S1's SID, which is 31, is greater than 22. So this can be there in the output, but this will not be joined with this. The reason is 31 is not greater than 58. Coming to this row, this can be combined with this, but not with this, because 58 is greater than 22, but not 58 greater than 58. So the output will contain, this is the output of this join. This 22 is not greater than 22 and 58, so this row will not be appearing in the output. So that is why we are not seeing this 22 here. I mean here. Coming to this one, 31 is greater than 22 and hence we are able to see this in the output. 31 AMI 819. 31 AMI 819 is combined with this 22 101 10 May. 22 101 10 May. So this is possible and this cannot be joined with this because 31 is not greater than 58. So this will not be there in the output. However, when we take the last row, 58 is greater than 22, so this will be there in the output. 58 rows 10, 21, 58 rows 10, 21, combined with 22, 101, 10 May. 22, 101, 10 May. However, this row will not be combined with this row because this 58 is not greater than 58. I hope theta join is now clear to you. In the similar way, we are going to apply the second join, which is the Equ Joint. And here, instead of having other operators, in Equ Joint will be having only equal to as the operator. Let's see that now. In the second type of inner join, which is the Equ Joint, this is also a special case of the theta join operation or the conditional join operation, where here this theta join uses only equivalence. It means equal to as the conditional operator. If the theta join that uses equal to as the conditional join operator, then it becomes the Equ Joint. So obviously this Equ Joint is also used to join two or more relations on some conditions like the basic inner join or the theta joint. Only difference is that this condition will be obviously using the conditional operator equal to. And the general representation is the same. As I told you, this is basically a theta join only. And obviously this theta is also going to be the same predicate. But the only difference between this Equ Joint and the previous theta joint is that here the conditional operator is going to be just equal to. When we are not using equal to and other comparison operators, then it will be the theta joint. If we use equal to, then it becomes the Equ Joint. However, this is going to be the same, the Cartesian product of two tables. And once the Cartesian product is performed, then apply the selection logic with some condition that uses equal to or equivalence. Let's see an example. the same S1 relation and R1 relation. But since we are dealing with Equ Joint, we are having equal to as the comparison operator. Let's take both the relations S1 and R1. Just compare S1's SID because S1's SID should be equal to R1's SID. Now in this case, S1's SID, this is S1, right? S1's SID 22 is matching with this 22, so these two rows will be joined. And coming to this row 31, there is no match for 31 here. And coming to 58, yes, we have a match for 58 here. The output table will contain only two tuples. One is 22, another one is 58. Only these two will be joined in the output relation. Let's see that now. Can you see? Yes. 22, 22. 58, 58. I request you to pause this video for a while. I wanted you to manually apply the Cartesian product and just generate the complete output of the Cartesian product and then perform the selection by giving this joint condition. I hope Equ joint is clear to you. Now let's move on to the third type of joint, which is the natural joint. Here, this natural joint is represented as the joint condition, but here it's not theta, whereas here it is represented as asterisk or simply star. So what is this natural joint? This is a special case of Equ joint. Remember, theta joint is the basic or the general case. Equ joint is a special case of theta joint. Now, this natural joint is a special case of Equ joint. Then what do you mean by this? Are we going to use equal to? Because basically Equ joint uses equal to, right? Yes, this is like this, but we are not going to specify explicitly the condition. Let's see that now. This can be, the natural joint can be performed only if there is a common attribute. Let's take there are two relations, and if there is a common attribute in both the relation, then directly you can perform natural joint. No need to specify any condition because the only condition is there should be a common attribute in both the relations. Obviously, it's going to use what? Equ joint only. So the condition is going to be equal to only, but we are not going to say which attribute of which table should be equal to which attribute of the other table. And that is why this is a special case of Equ joint. So basically, the name and domain of the attributes must be the same. For example, if you are comparing the student ID of S1 relation, and there should always be a student ID in the R1 relation, at the same time, the domain should be the same. Whatever values, whatever data type that student ID attribute is taking, the same data type, the same attribute, the same domain values, this R1 should also take. Anyway, if you are not sure about domains, just ignore it for now. Just understand the all possible values what can be for student ID of R1 should be the same as that of S1. And does that use any comparison operator? It should not, because basically it is a special case of Equ joint, right? And that is why this natural joint does not use any comparison operator. Basically, this uses equal to only. The main condition itself, there should be a common attribute, where the name and domain of the attributes must be the same in both relations. So what does natural joint mean? This natural joint basically is the Cartesian product along with this selection, along with this projection. Just perform the Cartesian product to get all combination rows, then apply the selection and just project whatever attributes you want. So the only difference between this natural joint when you compare with the other joints, where basically it is the selection that is applied on the Cartesian product, but this natural joint uses projection. So when we say that there is something special here where it includes projection, it means it does not do concatenation like the Cartesian product. So the Cartesian product concatenates both, right? But this projection or this natural joint uses projection. So this natural joint does not do concatenation like the Cartesian product. I know it will be not clear at this stage. I will show that shortly with an example. And this is denoted by the joint operation symbol, which is asterisk, simply star. It means this is natural joint. No need to explicitly mention any joint condition. Basically, it is an Equ joint, but only condition is there should be a common attribute in both the tables. That common attribute should have the same name and they belong to the same domain. And how it is represented then? If P and Q are the relations, it's simply represented as P natural joint Q. And how it is expressed in terms of relational algebra? It's Cartesian product It's selection and then projection. So Cartesian product is first, then the selection, and then the projection. So the Cartesian product is actually done, which is this, the selection, which is this, and then you project whatever columns you want. So projecting the required columns, whatever we wanted. So this is basically natural join. Let's now see an example for natural join. In this example, we are going to perform S1 natural join R1. Let's see the relations. S1 remain the same. Like in the previous example, we have the student ID, student name, rating, and age. Coming to R1, we have 4 attributes in R1 relation, which are SID, branch ID, rating, and date. Just pause this video for a while and just compare these two relations and just see how many common attributes are there. As far as natural join is concerned, we need not mention any condition explicitly. Basically, it is an Equ Joint. It is a special case of Equ Joint to be precise. However, we are not going to mention any condition explicitly, but the only condition is there should be at least one common attribute. In this case, are we having one common attribute or more common attributes? Student ID is here, student ID is here. The name is there, and also it seems from the data that they belong to the same domain. Let's say the domain is between 0 and 99, and all are belonging to the same domain. We also can see that the rating, the attribute rating is also there in both the relations. So here there are 2 attributes that are common in both the relations. Now the natural join is performed based on these both attributes. I mean, this student ID should be equal to this student ID. At the same time, the rating should also be equal. I mean, the rating value of R1 relation should be equal to the rating attribute in S1 relation. When both the conditions are matching, then they will be appearing in the output. Let's analyze. 22 is here, 22 is here, 7 is here, but this is 8. So the natural join condition is violated. Basically, it is a special case of Equ Joint. So this should be equal to this. At the same time, this should also be equal to this. So in simple terms, SID of S1 should be equal to SID of R1, and rating of S1 should be equal to rating of R1. In this case, this is not matching. Coming to this one, there is no entry for 31 here at all, so we can ignore this. And coming to this one, 58, we can see 58 here. So this is matching, but it should also satisfy one more Equ Joint. What is that? The rating should be equal. Yes, it is equal. And that is why we get in the output only one tuple or one row. Just pause this video for a while and think if anything is missing in the output table. I mean, any attribute is missing in the output table. Let me reveal that. Yes, the student ID is appearing only once and the rating is also appearing only once. If you keenly observe, this natural join removes the redundant attributes. So here the redundant attributes are student ID and rating. Here also student ID and rating. And the output, it contains exactly one time the student ID and the rating. If this was Theta Joint or Equ Joint, we will be having 8 attributes in the output, 4 and 4. But in this case, we have only 6. The reason is, it is a natural join. As per the natural join concept, it treats that these 2 SIDs are one and the same and these 2 ratings are one and the same because they belong to the same data type, the same attribute type, the same domain. It accepts all the values in the same domain. I hope natural join is clear to you. And if you recollect, I told you it's not merely Cartesian product and just selection. Here we have projection. Can you see here? If there is no projection, obviously we would be having 8 attributes, right? But here we have only 6 attributes. So which relational algebra operation gives only the desired columns? It's projection, right? Selection gives all attributes, but projection specifies only the set of attributes. So out of 8, we get only 6 in this case. Just pause this video for a while, and my question is, if you don't have an attribute called rating here, then how many common attributes are there between S1 and R1? Just contemplate, there is no attribute called rating. So what I am talking about is in R1, we don't have rating as one of the attributes, but the only matching attribute is SID and SID. Now in this case, if you perform S1 natural join R1, what will be the output? How many rows will be there when we apply the natural join between S1 and R1? Just perform this natural join and please let me know in the comment section that how many rows you will be having in the output relation. Use some creativity so that you can share this output itself in the comment section. And that's it, guys. So what we have learned in this presentation, we have learned about the inner join. To be specific, we have learned about the theta joint, equi joint, and the natural joint. I hope you guys enjoyed this presentation and thank you for watching.